Musicology commonly classifies scales as either hemitonic or anhemitonic. Hemitonic scales contain one or more semitones, while anhemitonic scales do not contain semitones. For example, in traditional Japanese music, the Anhemitonic scale is contrasted with the Hemitonic scale. The simplest and most commonly used scale in the world is the atritonic Anhemitonic major pentatonic scale. The whole tone scale is also anhemitonic. A special subclass of the hemitonic scales is the cohemitonic scales. Cohemitonic scales contain two or more semitones, making them hemitonic, such that two or more of the semitones appear consecutively in scale order. For example, the Hungarian minor scale in C includes F, G, and A in that order, with a semitone between F and G, and then a semitone between G and A. Ancohemitonic scales, in contrast, either contain no semitones, and thus are anhemitonic, or contain semitones, being hemitonic, where none of the semitones appear consecutively in scale order. Some authors, however, do not include anhemitonic scales in their definition of ancohemitonic scales. Examples of ancohemitonic scales are numerous, as ancohemitonia is favored over cohemitonia in the world's musics: diatonic scale, melodic major/melodic minor, Hungarian major scale, harmonic major scale, harmonic minor scale, and the so-called octatonic scale. Hemitonia is also quantified by the number of semitones present. Anhemitonic scales have only one semitone, dihemitonic scales have two semitones, trihemitonic scales have three semitones, etc. In the same way that an anhemitonic scale is less dissonant than a hemitonic scale, an anhemitonic scale is less dissonant than a dihemitonic scale. The qualification of cohemitonia versus ancohemitonia combines with the cardinality of semitones, giving terms like dicohemitonic, triancohemitonic, and so forth. An ancohemitonic scale is less dissonant than a cohemitonic scale, the count of their semitones being equal. In general, the number of semitones is more important to the perception of dissonance than the adjacency, or lack thereof, of any pair of them. Additional adjacency between semitones, once adjacency is present, does not necessarily increase the dissonance, the count of semitones again being equal. Related to these semitone classifications are tritonic and atritonic scales. Tritonic scales contain one or more tritones, while atritonic scales do not contain tritones. A special monotonic relationship exists between semitones and tritones as scales are built by projection, QV below. The harmonic relationship of all these categories comes from the perception that semitones and tritones are the severest of dissonances, and that avoiding them is often desirable. The most used scales across the planet are anhemitonic. Of the remaining hemitonic scales, the ones most used are ancohemitonic. Most of the world's music is anhemitonic, perhaps 90%. Of that other hemitonic portion, perhaps 90% is anhemitonic, predominating in chords of only one semitone, all of which are ancohemitonic by definition. Of the remaining 10%, perhaps 90% are dihemitonic, predominating in chords of no more than two semitones. The same applies to chords of three semitones. In both later cases, however, there is a distinct preference for ancohemitonia, as the lack of adjacency of any two semitones goes a long way towards softening the increasing dissonance. The following table plots sonority size, downwards on the left, against semitone count, to the right, plus the quality of ancohemitonia, denoted with letter A, versus cohemitonia, denoted with letter C. In general, ancohemitonic combinations are fewer for a given chord or scale size, but used much more frequently so that their names are well known. Column 0 represents the most commonly used chords, avoiding intervals of M7 and chromatic 9 THS and such combinations of 4th, chromatic 5 THS, and 6th to produce semitones. Column 1 represents chords that barely use the harmonic degrees that column 0 points. Column 2, however, represents sounds far more intractable. Column 0, row 5 are the full but pleasant chords, 9th, 6/9, and 9 all 5 with number 7. Column 0, row 6, is the unique whole tone scale. Column 2A, row 7, a local minimum, refers to the diatonic scale in melodic major/melodic minor scales. Ancohemitonia, inter alia, probably makes these scales popular. Column 2C, row 7, another local minimum, refers to the Neapolitan major scale, which is cohemitonic and somewhat less common but still popular enough to bear a name. Column 3A, row 7, another local minimum, represents the Hungarian major scale and its involution, and the harmonic major scale and involution harmonic minor scale of the same. Column 3A, row 6, are the hexatonic analogues to these four familiar scales, one of which being the augmented scale, and another the analog of the octatonic scale, which itself appears, alone and solitary, at column E equals 4A. Row 8. Column 2A, row 4, another minimum, represents a few frankly dissonant, yet strangely resonant harmonic combinations, MM9 with number 5, 119, DOM 139, and M711. As music tends towards increasing dissonance through history, perhaps someday column 2 will be as acceptable as even column 1 might be, and column 3 will finally have a place in the harmony of the world. Note, too, that in the highest cardinality rule for each column before the terminal zeros begin, the sonority counts are small, except for row 7 and the 3 columns of all sorts. This explosion of hemitonic possibility associated with note cardinality 7 and above possibly marks the lower bound for the entity called scale, in contrast to chord. As shown in the table, anhemitonia is a property of the domain of note sets cardinality 2 through 6, while ancohemitonia is a property of the domain of note sets cardinality 4 through 8, 3 through 8 for improper ancohemitonia including unhemitonia as well. This places anhemitonia generally in the range of chords and ancohemitonia generally in the range of scales. The interrelationship of semitones, tritones, and increasing note count can be demonstrated by taking 5 consecutive pitches from the circle of fifths, starting on C. These are C, G, D, A, and E. Transposing the pitches to fit into one octave rearranges the pitches into the major pentatonic scale, C, D, E, G, A. The scale is anhemitonic, having no semitones. It is atritonic, having no tritones. In addition, this is the maximal number of notes taken consecutively from the circle of fifths for which is it still possible to avoid a semitone. Adding another note from the circle of fifths gives the major hexatonic scale, C, D, E, G, A, B. This scale is hemitonic, having a semitone between B and C. It is atritonic, having no tritones. In addition, this is the maximal number of notes taken consecutively from the circle of fifths for which is it still possible to avoid a tritone. Adding still another note from the circle of fifths gives the major heptatonic scale, C, D, E, F, G, A, B, when the fifth is added from below the tonic. This scale is strictly ancohemitonic, having 2 semitones but not consecutively. It is tritonic, having a tritone between F and B. Past this point in the projection series, no new intervals are added to the interval vector analysis of the scale, but cohemitonia results. Adding still another note from the circle of fifths gives the major octatonic scale, C, D, E, F, F, G, A, B, when the fifth is added from above the top note in the series B in this case. This scale is cohemitonic, having 3 semitones together at E, F, F, G, and tritonic as well. Similar behavior is seen across all scales generally, that more notes in a scale tend cumulatively to add dissonant intervals, specifically, hemitonia and tritonia in no particular order, and cohemitonia not already present. While also true that more notes in a scale tend to allow more invaried intervals in the interval vector, there might be said to be a point of diminishing returns, when qualified against the also increasing dissonance, hemitonia, tritonia, and cohemitonia. It is near these points where most popular scales lie. Though less used than ancohemitonic scales, the cohemitonic scales have an interesting property. The sequence of 2, or more, consecutive half steps in a scale presents the opportunity to split the scale by placing the tonic note of the scale on the middle note of the half-step span. This allows a leading tone from below resolving upwards, as well as a descending flat supertonic upper neighbor, both converging on the tonic. The split turns a weakness, dissonance of cohemitonia, to a strength, contrapuntal convergence on the tonic. It is very common that a cohemitonic, or even hemitonic, scale, e.g., Hungarian minor C, D, E, F, G, A, B, be displaced preferentially to a mode where the half-step span is split, E.Cont, double harmonic scale G, A, B, C, D, E, F, and by which name we more commonly know the same circular series of intervals. Cohemitonic scales with multiple half-step spans present the additional possibility of modulating between tonics each furnished with both upper and lower neighbors. Western music's system of key signature is based upon the assumption of a heptatonic scale of 7 notes, such that there are never more than 7 accidentals present in a valid key signature. The global preference for anhemitonic scales combines with this basis to highlight the 6 ancohemitonic heptatonic scales, most of which are common in Romantic music, and of which most Romantic music is composed. Diatonic scale. Melodic major/melodic minor. Hungarian major scale. Involution of Hungarian major. Harmonic major scale. Harmonic minor scale. These cohemitonic scales are less common. Double harmonic major scale. Neapolitan major scale. Neapolitan minor scale. Ionian 5 scale. Persian scale. Locrian 7 scale. Adhering to the definition of heptatonic scales, these all possess 7 modes each, and are suitable for use in modal mutation. They appear in the table above in row 7, columns 2A and 3A. The following lists the key signatures for all possible untransposed modes of the aforementioned heptatonic scales using the note C as the tonic. Dmitry Timochko, in A Geometry of Music, Harmony and Counterpoint in the Extended Common Practice, ISBN 978-01953366672, includes hemitonia in calculation formulas for contrapuntal smoothness and harmonic force transfer. Brett Wilmot, in Mel Bay's Complete Book of Harmony Theory and Voicing, ISBN 978-15622299948, restricts the scope of his guitar chord voicing to ancohemitonic tetrads. Michael Keith, in From Polychords to Polya, Adventures in Musical Combinatorics, ISBN 978-0963009708, draws his list of basic harmonies as anhemitonic sonorities. All heptatonic and larger scales are hemitonic, ditonic or better, and tritonic. All pitch class sets of 7 notes contain 1 to 3 tritones and 3 to 6 semitones, as can be seen in their interval vectors on list of pitch class sets. All octavitonic scales save 1, the octatonic or diminished scale, are cohemitonic. All enneatonic and larger scales are cohemitonic. All sonorities with 5 or more semitones are cohemitonic. The set complement of a cohemitonic scale is often an ancohemitonic scale, and vice versa. Anhemitonic scales never have more than 6 notes, and are always ancohemitonic. Dihemitonic and trihemitonic scales never have more than 7 notes. Tetrahemitonic and pentahemitonic scales never have more than 8 notes. Hexahemitonic and heptahemitonic scales never have more than 9 notes. Octahemitonic and enneahemitonic scales never have more than 10 notes. There is no 12-ET scale with exactly 11 half steps. References